I had to learn more. I had a great appreciation of the limitations of my knowledge, and research was my way of learning, and had been it for my career. You see, I didn't go out on a sabbatical. I learned with my students and from my students. And so that was one part of it. The other part is I wanted to do biologically relevant work, because historically, up to, I would say, the 1950s, pharmacy was taught and behaved itself practically as a branch of chemistry. The orientation was totally chemical, at least that is my view. And schools like California and the drive of the students themselves who wanted relevance brought in the biologic aspects. So I wanted to bring that in at this old school that never had a publication in all its existence. I wanted to get going. And what was the easiest drug to use in those days? They didn't have acetaminophen. They didn't have any of the other commonly used drugs. People took aspirin. And I started working on aspirin. And the first work is simply to see, do these different aspirin products dissolve at different rates? Because my friend Eno Nelson at California had done fundamental work using pellets of pure drugs and shown that the salt, the sodium salt, for example, would dissolve much more rapidly than the free acid. And that's why sodium pentobarbital puts you to sleep earlier than, or phenobarbital, than phenobarbital itself, you see. So I looked at different tablets, and hello, they were all different and widely different. In those days, of course, all people did was measure the disintegration. And I, as time went on, pointed out I can make a tablet out of glass powder, and it disintegrates rapidly. It doesn't mean you absorb the glass. And as we looked at that and said, well, let's be a bit more rigorous now in looking at the absorption of the drug. Well, as you know, to determine absorption characteristics, you have to apply pharmacokinetics. And that drags you immediately from the evaluation of the dosage form into pharmacokinetics. And as we did this, we discovered something most unusual at that time. And that was that the drug was not handled by the body like most drugs, or all drugs in people's mind. Rather, the body seemed to have a limited capacity to metabolize a drug and sometimes to excrete it. We call that nonlinear pharmacokinetics. Now, the only example of that was not a drug, at least not generally noted as a drug. It was alcohol in Scandinavia. But when you consider the molecular weight of alcohol and of drugs and the doses used, alcohol was used in huge doses, you know, compared to drugs. And here, when a human took one tablet of the drug, you were already getting close to the ceiling of that human's capacity to metabolize the drug. And that, of course, as happens in research, continued to lead us into other avenues. Are there other drugs that are subject to these characteristics? What is their pathway? Why are they not metabolized in a concentration proportional manner, but rather in a lesser, at a lesser speed when the concentrations are high? And that got us into things like product inhibition, just going to the biochemistry textbooks and